Hi, I'm James. My purpose today is to show you guys how to quickly, cheaply, easily, and reliably transmit data. I have used what I've learned to control a remote control car with Arduino, and I'd just like to show you guys how I did that. I've experimented with two types of modules. One are these AM modules, 315 megahertz, and I haven't had a lot of success with them. I've spent a lot of time trying to figure them out. I have had a lot of success figuring out how libraries work from them, but not a lot of success with actually controlling a remote control car. These are the 5 of the 7 pins that you'll be connecting to your Arduino. You connect those 3 and those 2 data pins. Those data pins control the module. And then you also have to plug in power and ground, so VCC and ground. And you make sure that power's into 3.3 volts or less. These modules don't work at 5 volts, that'll burn them up, so make sure you plug them into 3.3 volts instead of 5. Okay, to hook up the modules to your Arduino, you'll want some pins that are like this. See, they have the needles at one end and they're open like the Arduino at the other end. And these are useful because the MIRF24L01 modules, they come in a 2x4 matrix and you can't plug them into a breadboard and have an individual row for each pin. So basically you need something like this to hook them up, and then you can hook them to your breadboard, or you can even hook them directly to your Arduino with this, which I have done. And just wanted to suggest that so that you don't get your board and wonder how to hook it up. Alright, so now I've opened the Arduino IDE and go to Examples, MIRF, Ping Client and Server, File Examples, that's the client, so I need the server. And the first time I did this, I actually had the client and server on the wrong. Well, anyway, it didn't work because you look here, I put the MIRF file inside this other file. I think that's how it came. And anyway, it didn't compile until I put MIRF separately. So you can see Aaron's MIRF, and then this other one is just MIRF, and they go to the same place. But these ones won't compile, this one will. So, talk through the code. Start with the client, I guess. This is the baud rate. Those are the libraries. Void setup, baud rate. I'm not sure everything that these do, but when you get the library, you can look at the code and try and figure that out. But the CLIL is the name of one of these, either the sender or the receiver. This has got to be the receiver's name. And then payload size, config, beginning. So I'm not sure much of what that stuff does, but I know how to manipulate it to get it to transmit. So basically it'll send from your client to your server. This long gets the time, it sends the time as a byte, receives the time over here, and then what this one does is it sends the time back, and you get the time down here and delete it. But if you're going to do what I did for a remote control car, to start out you only want to transmit one direction. So basically, look over here. You don't need this. You don't need that. You don't need that. So you can just, and you won't be able to save it, but you just want to get the data and then probably serial.print data. And you compile it, Let's see, what did I do? Data at where. So the data here is a array, so you just have to tell it where, and then it should compile. And I'm pretty sure this code is a lot more complex than what I'm using it for, but this is a simple version, and maybe there's a video somewhere that shows more of how to use it. But go to void loop. Instead of saying time, you can make a variable, call it time, and then we'll go up here, make a variable. Vars for variables, and message. I need to type int message about byte, then I'm gonna have to change it. Byte message. Just leave it as that for now, and then you can come down here. The useful thing to do is analog read, say pin 0, and what do you want to analog read to? You want to send it to the message. Now analog read is, a byte can go up to about 256, analog read is 4 times that, so just divide analog read by 4, and then you can change the send byte to oh, okay, so there's an extra parentheses, and it works. And so you could hook up a potentiometer or some sort of a switch to your 0 input for analog, and you'd get a message from 0 to 255 or so that would send off to your server, and after you get the data at your server, you can use it for whatever you want. I wanted to finish up with an electronics pun. Why did the capacitor kiss the inductor? Because he couldn't resist her.